All right, guys, Mr. Antonucci here. And in this video, I want to talk about what you need to know as you prepare for the AP Stats exam. As you can see on the screen, so you're about to take the AP Stats exam. So let's talk about the multiple choice section first. There's going to be 40 multiple choice questions on the exam, and that's going to account for 50% of your score. Now, considering a 50-point possible score for the multiple choice section, each multiple choice question is going to be worth 1¼ points. Unanswered questions do not count in the scoring calculation. Okay, so it is to your advantage then when you are taking it, if you don't know an answer, to guess, especially if you can eliminate one or more of the choices there. So there's going to be two main types of multiple choice questions. One is going to be a content related question, and one is going to be a calculation type question. So the content or concept type questions are not going to really deal with math per se, where you're going to be making calculations. They are constructed so that they can really get at your knowledge and understanding and ability to apply statistical concepts in a contextual situations. So the answer choices are going to be, they're going to be verbal. You're not really going to have to require, I mean, you might have to do some simple things, but nothing really major. And they should take you very little time to answer. And you can expect anywhere from 10 to 15 questions per exam. That's kind of been the historical, how it's been. Now, the calculation questions, those do involve math, and some of them may consider, may contain a considerable amount of math. And those are designed to test your ability to use the concepts and knowledge and understanding to calculate appropriate answers. So your answers there are going to be more numerically based. You're going to need to use the formulas, the table, and or you might have to use the calculator for these types of questions. Now, these ones will take you a little bit more time to answer, and they do account for a majority of the test on the multiple choice section. So a typical concept question might look like this. A simple random sample of size n is taken from a large population whose distribution of the variable under consideration is extremely right skewed. Which of the following statements is true? And then you would read the following statement. So this is a concept question. You're not really going to have to make any calculations. You just have to understand the concept. Now, the next question is a typical type of calculation question. A 95% confidence interval is to be calculated in order to find an estimate for population proportion. What is the smallest sample size that will guarantee a margin of error of at most 5%? I'm not going to calculate it, but you would have to perform some calculations, perhaps even with your calculator, to figure this one out. So this is kind of the distinction between a concept type question and a calculation based question. Now, there are some things that you can do to increase your multiple choice score. Do use your time wisely. You have 90 minutes for the 40 questions. If you simple math, that's going to be 2¼ minutes per question. Now, some questions will take less time than that. Some questions will take more, but on average, you spend a little bit more than 2 minutes per question. However, you don't want to necessarily work consecutively. You want to do the ones that you know first. I mean, of course, you're going to start with one, then proceed to two, 3, 4, and so on. But it's okay to skip around. If you read a question and you are confident you know how to answer that, go ahead and do that problem. But if the question seems tough or unclear, or you're unsure about what to do, mark it down and move on to the next one. You do this so that you can first make sure that you're answering all the questions that you are confident about, so that you don't spend an extremely large amount of time on one question that you don't even know how to do, and then you run out of time and miss 4 or 5 questions that you did know how to do. You just ran out of time. So by following this process, you can answer all the ones you know first, and then come back and tackle those ones that were unclear. And sometimes what happens is, as you work through, your mind remembers some things and you're like, oh yeah, now I remember how to do that. So be careful there. And remember, all the multiple choice questions carry the same value. So you don't want to run out of time because you spent all your time on a difficult question that you didn't even know how to do anyway, and then you missed couple that you would have known how to do, you just ran out of time. Okay, so the free response section, you're going to have 6 questions there, and those 6 questions are going to be worth 50% of your score. You're going to have 5 essay questions, excuse me, and 1 investigative talk. The essay questions will represent the 4 main topics of statistics, so analyzing data, producing data, probability, and random variables and inference. And on average, they should take you about 12 minutes each. You may spend more time on one and less time on another, and they are worth 75% of the section 2, which comes out to be 37.5% of the entire test. Now, that being said, the investigative talk will test several concepts and procedures that you've learned throughout the entire course in the context of a single problem. So it's kind of seeing how you can cohesively put together everything that you've learned through the course. Now, of course, they're not going to be able to put every single concept on there, but it's going to be a very robust type of question. This one's going to take a little bit longer, about 30 minutes, and it's 25% of section 2, which comes out to 12.5% of the entire test. So this one's pretty heavy, pretty significant, and as far as time to take it, and also the amount of the test that it takes up. So there's some information there for you. Now let's talk about problems where you have to make a graph. Make sure you label and scale your axes. Do not copy the calculator screen, exactly as it is onto the test, because you need to put the scaling and the labeling. And don't refer to a graph on your calculator that you haven't drawn. I've seen students, even in my own course, where they will check conditions for a certain hypothesis test, and they'll appeal to the graph, and they didn't put the graph on their paper. You have to put the graph down. You have to show the data display, even if you generate it on your calculator, if you refer to it. So just transfer it to the exam, make sure you label and scale your axes, and that's just part of doing good statistical communication. Also, on that note, make sure you communicate your thinking clearly. Organize your thoughts before you write, just as you would on a paper, in English paper, we have to write an essay. Make sure you write neatly and clearly. I can't tell you how many times I've had to return a student's paper because I just could not read it and decipher it. It might have been right, but I couldn't tell what they wrote down. Write efficiently, say what needs to be said, and move on. Don't ramble. And it's your job to communicate, okay? It's not the grader's job to try to decipher what you really meant. So make sure you communicate clearly using correct statistical terminology and vocabulary. Try not to contradict yourself. Don't say one thing and then I've seen students do this. And this is a very technical piece of statistics, is being able to communicate ideas clearly without contradicting yourself. Parallel solutions are graded on the incorrect answer. That means if you kind of show 2 ways to do the problem, or 2 aspects of the problem, and one of them's right, one of them's wrong, they're going to grade the incorrect one because you did have something incorrect there. Now, avoid bringing your personal ideas and philosophical insights into your responses. Sometimes the context of the situation touches on a hot topic, or a topic that's in the news, or you feel strong, you have strong personal views about. That doesn't matter in statistics, and you don't want to get into it. It just clouds your communication. When you finish writing your paper or your answer, look back. Does it make sense? Does it flow? Does it address the context of the problem? That's another big thing, is I will see students, write up a summary, write up a conclusion, and it doesn't have any context in it. So that's another important thing. About using the graphing calculator. Make sure you don't spend an inordinate amount of time plugging data into your calculator when it isn't necessary. Make sure you read the whole question and see, do you really need to put those 52 numbers into a list? Sometimes you really don't. It's time consuming, and if you're just mindlessly plugging numbers into a calculator because you saw a list of numbers or a table of data, that's not very statistically intelligent, if you will. Don't write directions for the calculator button pushing on the exam. The sequence of buttons you push on the calculator, while you may need to know that, that is not like a good way to display statistical information, as well as using calculator syntax, such as like normal CDF or one prop z test. Write out the name of the test, say what you did, write a complete sentence. Also, make sure you're following directions. If a problem asks you to explain or justify, make sure you do that. Make sure you explain, make sure you justify, but at the same time, don't get too wordy. Don't write down everything you know, because you're going to be graded on everything that you write. And the more that you write, if you get very verbose and you're just writing all kinds of stuff, you're increasing the likelihood that you're going to cloud and be confusing. And if part of your answer is wrong, you're going to be penalized for that. We talked a little bit ago about parallel solutions. So decide on the best path for your answer and follow it through to the logical conclusion. If you provide multiple solutions to a single question and one of those solutions is correct, one of those solutions is incorrect, you will be scored. Your response will be scored based on the incorrect solution. Okay. Also, another thing to keep in mind is just because you have a certain amount of space on a free response question doesn't mean you need to fill it all up. So if your response doesn't fill up the entire white portion on the test, that doesn't mean you did something wrong necessarily. They're just giving you space. So and another thing is, like, if you can't get an answer to a particular part of a question, often these free response questions have several parts, make up a plausible answer to use in the remaining parts of the problem, because sometimes the answer you get for part A is carried through to part B, to part C, to part D, and so forth and so on. And if you're not confident on your answer to part A, but you understand the process and procedure for doing part B or part C, try to come up with something for part A and then carry that through. Because sometimes what will happen is, yeah, you might lose the point for what the answer was for part A, but then if you carried that wrong answer correctly through the process and explanation and testing, whatever you're doing with it, through the rest of the problem, you're more likely to earn points, even though you used a wrong answer from part A, but you did the rest of the processes and procedures correctly. So just keep that in mind. And here's some things from a chief AP reader after the 2001 exam. This is old, but this is very good information. Areas that continue to be problematic. Many students failed to read questions carefully and, as a result, answered a question different from the one that was asked. I see this in my class every single year with multiple students across all of my classes. You have to read all of the directions in all of the context of the problem. Many students did not answer questions in context. Explanations and conclusions in context are always required for a complete answer. So make sure you understand what it means to answer a question in context. You can't just like write the general, conclusion from a hypothesis test without stating the specific, particular context from that problem. More students than in past years stated assumptions when carrying out a hypothesis test, but few understood that assumptions must also be checked. On that note, when you're checking the conditions, you can't just write down, random condition, check, 10% condition, check. You have to give a little bit of information to show how you know that that condition is checked. A large number of students seem to believe it's okay to draw conclusions just by looking at the data, and it did not seem to understand the need to employ inferential procedures even when asked to provide statistical evidence to support their conclusions. Okay, so free response scoring breakdown. You can get 0 through 4. A 4 is like an exemplary answer. You have a complete response, you have no errors, you have clear communication. And then you could see, if you want to pause the video here and just read down through this, I'm not going to just read this slide out to you, but this is the basic rubric that they're going to use. Because some of this, it's not like a regular math class where you have to use an equation or formula and solve for the answer, and then maybe state what that answer means in the context of the problem. There is some gray area, so they have to grade based on a rubric. Okay, so on the AP exam, you will get a formula sheet with the formulas, but they will not tell you how to use them, when to use them, and they will not show you the steps for how to do these different statistical procedures on a calculator. So what I have here is, this is a couple slides long, but it's the the procedure, the formula, the conditions, if any apply, and the calculator options. So what I'm going to do is I'm going to bring each slide up, and you can pause it. You can copy this down if you want. And I'm going to try to put a link below to this whole presentation so that you can easily access it. But make sure you just pause it, and then you can copy it down if you want. So here's these. And then here's inference procedures as well here. And then here's two sample means and proportions. Here's some more. Here's categorical distributions, some slope. Okay, now back to during the exam. Make sure you relax, take time to think. Remember, everyone else is taking an exam, and they're probably just as nervous or excited as you are. Some of the problems may look considerably more complicated than those you've encountered in other math courses. And that's because statistics is necessarily a wordy course. In other words, you're going to be doing a lot more writing than, and you should be used to this by this point in the year. Make sure you read each carefully before you begin working, particularly for problems with multiple parts or lengthy introductions. Make sure you read the whole problem. Don't just assume you know what they're going to ask without reading the entire question. I can't tell you how many times I could tell a student assumed they understood what the problem was asking for and answered what they thought it was asking for, and I could tell they did not read the directions. If you want to highlight keywords, that's a great thing to do as well. Also, look at graphs and data displays carefully. Look at how they're labeled. Look at how they're scaled. Look at what they represent, because this can be very, very telling, and they can ask you questions based on that you need to understand what that graph is actually displaying or what that table of data is actually displaying. Now, with the graphing calculator, it is meant to be a tool. You don't have to use it for every single problem. Lots of problems, you will have to use it, but it's not going to make up for not having a brain. So make sure that you use your brain. You use the things that you've learned, that you've been taught, that you've studied, that you've prepared for. Use your brain to think through things. There isn't always a step-by-step procedure for answering every single question. Sometimes you have to think through the question to figure out, okay, what are they asking for? How might I use what I know to answer that? On multiple choice questions, make sure, again, read the entire question, examine it carefully. What topic is being tested and what's the purpose of the question? Highlight keywords and phrases if you need to, or underline them. After you decide on an answer, make sure you go back and see, does it make sense? Keep scoring in mind. Now, they have changed this. They used to do the number correct minus 1/4 of the number you got wrong. Now you just get a point. Basically, it's like you start from 0 and you get a point for every question you get correct. So it's to your advantage that if you don't know the answer to a question, to go ahead and guess, particularly if you can eliminate one or more of the answer choices, then it's even more to your advantage because you've increased the likelihood of guessing correctly. So I would add that you do want to answer all of the question. Now, if an answer choice seems obvious, think about it. If it's obvious to you, it's probably obvious to others, and chances are it's not the correct response. Sometimes the questions are fairly easy. They have all levels of questions, from fairly easy to like extremely hard that almost nobody gets correct. So for example, suppose one set of test scores has a mean of 80 and another set has a mean of 90. The two sets are combined. What is the mean of the combined scores? The obvious answer is 85 because that's the average of 80 and 90. And that's probably going to be one of the answer choices, and that's probably going to be the one that a lot of people think to pick first. But you realize after going through a stats class that 85 is not necessarily the correct response, because you don't know if combining those means in that way, because you don't know the size of the size of each data set that they use to get the mean of 80 and to get the mean of 90. So if the average test score for the first set of tests was on 10 tests and you got 80% there, but the second average was based on a set of 150 tests, then when you combine those, yeah, the average of 80 and 90 is 85, but the total average over all of those tests is not going to be 85. Okay, so on free response questions, don't feel pressured to work all the free response questions in a linear fashion, just like we talked about with the multiple choice questions. Pick off the low-hanging fruit first. Typically, question 1 is going to be more of a straightforward type of problem, and you might want to start with that, but then move on to another problem that you feel confident about. But make sure you don't run out of time before you get to the last question that you need to do, particularly question 6. That's the investigative talk, and that counts almost twice as much as any of the other questions. Now, you want to read each question carefully, sentence by sentence, highlight, underline, those kind of things. Make sure you understand what statistical concept or idea is being tested, and that's going to help you choose the proper approach, and then using your formula sheet, which formula to use. Now, you don't have to answer these problems in a paragraph form. Sometimes a bulleted list or of bullet points or an algebraic process is going to be preferable. And answer each question in context, and make sure you answer the question that is being asked. Well, that's it. We just covered a ton of stuff as you're about to take the AP Stats exam. I hope that was helpful to you. Let me know in the comments below if it was. If you have any other tips or pieces of encouragement or things to look out for, put them in the comments so other people can benefit from what you know. Also, make sure you subscribe to the channel and hit that bell for notifications when new videos are uploaded. All right, guys, take care.